All right, so I think what the format here is we're just going to go through like a whole bunch of like Go history and Go present kind of as quickly as possible, and then we'll kind of open it up to just Q&A and talking about Go. Does this work? Yes. So yeah, the talk is basically the Go's past, and then Go's present, and then Go's future. I'm Brad Fitzpatrick. I generally go on the internet just by Brad Fitz. I've been working on Go almost about 5 years now, and I work on some other things on the side. My kind of side project is this camlystore.org life indexing archive search east system. But pretty much I always go back to Go, and I'm pretty much always working on Go. As a first show of hands, who actually uses Go? Excellent. So I don't have to actually give a Go tutorial today. If you don't know Go, it's kind of a nice little language. It's very small. It's kind of a nice blend of scripting languages being like letting you get stuff done quickly, and low-level languages letting you get things done like performance-wise. I always say that there's like languages that are good for the computer and good for the human, and I think that Go is like a happy mix. It's like 80% good for the human and 80% good for the computer, and that's better than having to make a trade-off at the beginning of a project about what you care about. So, a quick summary of Go's past. Prior to like November 2009-ish, there was probably 3 or 10 people inside Google that were using Go and kind of complaining about, well, basically they were complaining about C++ inside Google because everything in Google was in C++ and pretty much painful. Like the compile times took forever. And so the story goes that Rob Pike and Robert Griesemer and Ken Thompson and others were basically just complaining about how much computers sucked and how slow compiles had gotten while they were working on like Google Maps or something like this. And they were just waiting for it to compile, and they started thinking about like, couldn't we make a programming language that was better and didn't have such terrible properties? And they were actually at a meeting of like deciding, or a presentation about Google's, the people that were working on C++, what was it, C++ X3, or is this thing crapping out? Okay. Anyway, so they were watching a presentation about the next version of C++, and it was just C++ was adding more and more features, and C++ was already like disgustingly large. And they thought, couldn't we have something that was simpler? And so this was basically what became of Go, and it was kind of an experiment for a while. And once it got going, they realized that this was actually useful, and it was really nice to have a really simple language that was also fast. Because inside Google, we have languages like C++, which are a pain in the ass for humans, but really fast for the computers. Then we have languages like Python, which is fun for a human sometimes, and then really slow for computers. Like we can't actually deploy a service in Python without like being fiscally unresponsible with our data center resources. So it was open sourced in November 2009. It was still even pretty immature in 2009, but there was like kind of a taste of what it would become. And so I remember seeing this blog post and seeing some presentations a few months before this. And so I was on the bus. I was working on Android at the time, and I was on the bus between San Francisco and Mountain View. It was something like, it's supposed to be 45 minutes, but in practice it's like 4 hours a day wasted of your life, just like sitting on a bus going back and forth. So I started hacking out this idea of mine, which was camlystore, and hacking it on in Go because I was like, well, Go can actually compile on a single machine, on a single laptop, and compile really quickly. And I couldn't imagine writing this program in Perl, which was my old language that I used all the time. And I couldn't imagine using Python. I couldn't imagine using Java or C++. So I decided to experiment in Go. And of course, I found a lot of things in the standard library just didn't exist or were buggy. So I just started hacking on Go. At the time, the website looked like this. It wasn't much, but it said it's simple and it's fun and expressive. And so I started playing. Yeah, it's simple, fast, safe, concurrent, fun, and open source. And it is still all those things. It's still a very simple, small language. It's still really fast and safe. Concurrency is kind of the best part of the language. You don't have to think about callbacks. You don't have to think about threads. You can have an HTTP handler that just does one thing and then does the next thing and then does the next thing. And it doesn't matter if each one takes like minutes or milliseconds. You just write top-down code. So it's really refreshing to write code like that. Even in 2009, when the language was first open source, there were 2 compilers. There was the GC compiler, which is kind of the main one you probably download from golang.org. And then there was the GCC Go compiler. But as in like an aside, when I say GC lowercase, it means the Go compiler in Plan 9 terminology. It was kind of a fork of the Go. It was Ken Thompson's C compiler kind of adapted to do Go. And then when I talk about GC capital, that's garbage collector. So that's always confusing when we speak about it, but people generally know from context what we mean. So in 2009, there was already basically five-ish, six-ish versions. There was the 32-bit and 64-bit Linux ports. There was the ARM port, which someone kind of did as an experiment, but it was kind of terrible and didn't work that well. And then there was the Mac 32-bit and Mac 64-bit ports. And then there was the native client one that kind of worked, but it later bit rotted and died, but it was kind of there. And if you wanted to use more, if you wanted to use like MIPS or PowerPC or Spark or other operating systems like Solaris or whatever, you can kind of use GCC Go for some of those, IRIX or something. But I never really used those. For me, like either on my Mac or on my home servers, one of the 32-bit or 64-bit Mac or Linux was generally good enough. So even in 2009, there was stuff like GoFumped and GoFix. And who uses, everyone, all your code GoFumpted? Yeah? Did everyone know it was pronounced GoFumped? It's kind of weird. So over the years, originally the releases were called weekly whatever, and there was a release once a week. And everything broke. Like whole APIs would change, language semantics would change, and pretty much you had to change your code once a week. So then there was this tool, GoFix, where the idea was rather than make everyone change their code every week, we would instead write a tool that would update your code to the latest version. And so that came really pretty early, and it fixed most of the problems. So we tried to always make it that when we updated the language or updated the standard library, we would make a GoFix rule. So you just run GoFix dot or whatever on your directory and update all your code. After that, we switched to breaking your code only once a month instead of once a week. And we called those releases R whatever, R56, R57. I think it went up to like 60 or 61 or something. But at the time, there was no Go tool, so there was no Go build, Go install, Go get. You had to write make files, and it kind of sucked. The big release was Go 1.0, and this was, the beginning of 2012. This is the release that finally introduced the error type. Previously, it was called os.error. It was in the OS package. We added the delete built-in to delete things from maps. Before, you did like assign value comma false, so you had two R values on the right assigning to the left side of a map. But people always found that a little weird, so we finally caved and added a delete built-in. We also, the main thing in Go 1.0 was we added this stability promise. So if your code worked in 28th of March into 2012, your code will still work today. We try not to ever break your code. So we have this API check tool that makes sure that we check into our repo kind of a signature of all of our external APIs, in addition to all of our unit tests. So we basically, this catches us from accidentally changing the API that we ship to you, so your code will still compile, and hopefully the unit tests make sure the semantics didn't change at all. But more than that, more than like mechanical testing, is basically a promise that if we see a code review come in and you even slightly change the semantics of the language or the Go standard library, we basically say, no, sorry, your way may be better, but we just can't accept it because it might break someone's code somewhere. So there's a lot of stuff in Go 1 that we kind of regret, but we can't fix it at this point. So maybe if there's ever a Go 2.0, we'll fix a lot of these mistakes, and we've been keeping a list of them, but there's not that many. So this was end of March 2012, and over a year later was Go 1.1. So this release took way too long. We didn't really have a plan for when we were going to do the next version of Go, and it took over a year. There wasn't much difference. This is the release that added method values, so you can say like, you can refer to a method from its receiver. So here, S is the receiver name from this struct, and you can refer to a method, and then this has type, a func that takes nothing, so you can use it for like async.once. So tiny language change, but it was nice. There was also the terminating statement rule, so a function that returns something doesn't have to end in a return statement if every path through the final statement also ends in a return. So minor language change. This was also the release that said int, the size of int depends on whether your machine is 32-bit or 64-bit. Prior to that, it was always 32-bit, so we can only have 4 gig heaps, or you can only have arrays with, like 2 billion elements. So people started using Go for like bigger problem domains after this because you could have, use all the memory in your machine. The compiler got better, the standard library got bigger. We started to have a precise garbage collector in Go 1.1. As a little aside, I don't know how much garbage collection knowledge everyone here has. I didn't have much at the beginning of Go. But basically, you have all this memory. You can think of it just like all these little 32-byte or 64-byte words of memory. And some of them might be pointers. Some of them might be just the number 5. Some of them might be a Boolean that looks like a 1 or a 0, but maybe it looks like a pointer. You don't really know. So the old garbage collector, kind of just what you call a conservative garbage collector, just goes over all the memory and says, does it look like a pointer? 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 And where it looks like a pointer just meant, is it kind of in the range where we keep our memory? If it's lower than a couple meg, it's like in the kernel's address space or something. And if it's or lower than a gig or something, and if it's like in the range that we've allocated from some mmap or something, then it's probably our memory. And then you just only get rid of the pointers that you don't have. So it was a really naive garbage collector. It kind of worked, but the problem was on 32-bit machines, it kind of sucked. And in particular, that meant for ARM machines, which are almost always 32-bit at the time, the garbage collector kind of sucked. And a lot of people complained on Windows because most Windows users would download the 32-bit version because most Windows installs at the time were 32-bit Windows. That they would say, oh, the Go garbage collector sucks. It doesn't work. It's not returning all the stuff. And it just so happens when you have 32-bit pointers and the 32-bit ints, pretty much all numbers kind of end up looking like a pointer because there's just not that many numbers between 0 and 4 billion. So you would have some random table of data, and most of those numbers would end up looking at pointers. So in comparison, in a precise garbage collector, the runtime and the compiler keeps all this information, so every little bit of memory knows exactly what it is. So if this is an int that has the value, 1.5 billion something something, and this is a pointer that has 1.5 billion something something, it knows that, well, I don't have to collect this and follow it in my mark and sweep algorithm because it's just an arbitrary number from a user that's 1.5 billion, but this one is an actual pointer I have to follow. So anyway, so an increasing theme across all the Go releases has been to move from a conservative garbage collector to a precise garbage collector. So Go 1.2 came out. This one was 6 months later. This is when we started our policy that a new Go release would come every 6 months. And so this one did come about, this was May, and then this one came, December. So they started to be about every 6 months. Little language change is you could set the slice capacity with a 3-index slice. This was kind of controversial for a while because people thought it might confuse Python programmers because in Python this is like the stride, but no one ended up getting confused. We started to have a preemptible scheduler, so if you had one Go routine that was just like spinning and using the CPU forever, we could actually interrupt it to run the garbage collector, where before you can make a program deadlock basically by having a Go routine that got stuck and spinning off on the side or doing some large computation. Go 1.3 was exciting because it had no language changes. There were some changes to the standard library, but it mostly just added lots of new support for operating systems. There was Solaris, a Dragonfly BSD, which was a fork of FreeBSD, Plan 9, native client was fleshed out again. It was brought back from the dead. And now the stack was mostly garbage collected. Previously in Go 1.2 and 1.1, we started to do precise garbage collection of the heap, but not the stack. But it wasn't totally accurate. It was mostly accurate almost all the time, but we couldn't rely on it, but it helped. Mostly the Windows users stopped complaining and the ARM users stopped complaining, and it also almost had contiguous stacks. So previously, in C, when you allocate a new thread, you generally get like I think I have a picture. Yeah, so in C or Java, if you do like a new thread, you get this gigantic stack frame. So just in case you call a function that calls a function that calls a function that calls a function, you have plenty of stack space available. The problem is that makes threads really expensive, so you can't have lots of them. In Go 1.2 and before, every Go routine only got a 4K stack, and when you ran out of stack space because you called a function and you didn't have enough space to fit, it would just allocate another one, and then if you ran out of stack space in that little 4K one, you would allocate another one, and they would be all over the place in memory. So you'd have a little one over here, a little one over here, a little one over here. But the problem is, if you were just slowly growing and slowly shrinking, that was fine. But if you happen to be like decoding like some gzip or some JPEG or some JSON or something, and you were in this really hot path where you were calling a function, and you were right on the edge of this little 4K boundary, and you had to allocate a new 4K frame, and then you returned from that function, and then you went back into this other one, this little hot split problem where you were like allocating and deallocating these 4K stack frames just on the boundary caused these massive performance dips. So this is a benchmark that somebody on a team did at the time that said, as a function of the bytes per the initial stack segment, because normally we started at like 4K, so he started at like 3.5K and just worked up by a couple bytes. This was how many megabytes per second we could decode of JSON. And you can see that like the numbers just all over the place. It's basically random. You get unlucky at some sizes, you get more lucky at other sizes. So when we were doing profiling of Go stuff, sometimes we would just add a local variable, we would add a function, we would refactor some code, and the performance would get twice as good. And then we would delete a variable, and then the performance would get twice as bad. And so it was really hard to like profile really performance-sensitive code because if we got unlucky with the stack frames, the size of them, that the performance would go all over the place. So we realized that this whole segmented stack that Go did from 1.2 and below was kind of a bad idea. So in Go 1.3, instead what we wanted to do was have one tiny little stack that starts out like 1K or 2K or whatever, and dynamically grows and shrinks. But the problem is, when you grow it, like if your stack frame is only 1K and you want to grow it to 2K, you may not have space to grow it in place to 2K, because there could be something in memory after that. So you have to like allocate 2K over here, and then you have to copy this 1K to this 2K region. But then the problem is all those local variables you had on your stack that might be pointers and might be integers, you can't rewrite, you have to rewrite the pointers, but you can't rewrite an integer to something else. If it was the integer 7, it has to still be the integer 7. It can't be like 1.5 billion plus 7. That would be like the program would have the wrong answer. So to do this, we had to actually keep track. We had to be precise. We had to know type information for the stack and stack information for every local variable on the stack and the heap. So this kind of helped garbage collection, but it also helped us have segmented stacks or contiguous stacks that we could copy and shrink in place or like out of place and rewrite all the pointers without messing up with the integers. So it turned out that if you get your stack big enough, performance is awesome. So now in Go 1.4 and up, the stack is just, or the Go routine stack is just as big as it needs to be and dynamically adapts. So compared to 2009 when Go was released, we now have Windows support, which we didn't have when Go first came out. The community did all that. We have FreeBSD, OpenBSD, NetBSD, Dragonfly, which are all BSDs. Someone did Solaris. Another part of the community did Plan 9. People, and a lot of the Go team actually, for an App Engine, originally used native client, brought that back to life. So we have a lot more operating system support. There's lots of documentation and books now. How has actually everyone here learned to Go? People learn from like tour.golang.org, books, blogs, blind feeling through the dark and seeing until the compiler is happy. But yeah, the tour. Yeah, I like the tour. But when we first started, there was very little documentation. We've tried to like keep the blog and stuff updated, but now there's tons of books. Everyone always asks us for books. We keep all these stats about like how many people were on the mailing list. I just updated this number right before this talk, that there's now some almost 16,000 people on the Nuts mailing list and almost 2,700 people almost on the dev mailing list. And so everyone seems to be using it for cloudy stuff. All the like Heroku and Git tools are switching to Go, and everyone's heard of Docker and CoreOS and all these sorts of things, Kubernetes, and so everyone seems to like this sort of stuff for like low-level-ish system sort of things that let you do system calls and like align memory and like do whatever you want, but not be have threads and have Go routines, but not have to deal with C++. And, like it's a great mix of like Python and C++. If you hate both of these things, but you kind of like both of these things, like Go is kind of a great language. There's a bunch of conferences. GoCon Tokyo has a conference like once or twice a year. They've been doing that a bunch. There's GopherCon in Denver. It was sold out last year. They were going to try to do 500 people, and then they made it bigger, then they made it bigger, and they ended up selling out all 750 tickets. And this year they're doing it again, and their plan is to do over 1,500 people. So they're trying to find space for 1,500 people. The one in Paris last year was awesome. This year I think it's November 3rd in Paris, and it's a pretty awesome Europe Go conference. There was just one in India. And now this year, there's like 7 or 8 of them. So first there was like 1 per year, and then there was like 3, and now there's like 7 per year. So there's lots of Go conferences going. This is an awesome bus that people at CoreOS did. Apparently, if you want to like put a big vinyl sticker on a bus, it doesn't actually cost that much. I didn't even know that there were companies that did this, but there you go. The cool thing about CoreOS is when we first did the Go dashboard, this is the dashboard that tells us like all the revisions that we check into Go and all the operating systems and the architectures and all the build configurations. This thing was originally kind of a Python app on App Engine, and we had just machines that were sitting there polling the Python App Engine app, building and reporting to it. But nowadays, this is all written in Go. It's running on Go App Engine, and each one of these boxes was a virtual machine that started up. And a lot of these were like all spun up in Docker containers. And some of them were virtual machines running on other things. But pretty much this whole dashboard now is powered by like, Docker and CoreOS and App Engine things. Like this is all like powered by Go, which is pretty awesome. That when we started off, we were having to use Python for our whole build infrastructure. And nowadays we're using stuff that the community has built for us. So that's exciting. Oh, look at that. So yeah, there's fun tools like wait, so everyone said they use GoFumped. Who uses Go imports? Who doesn't use Go imports? Shame. Shame on all of you. Anyway, if you're sick of adding and maintaining your little Go import of your import lines, like be lazy and use this instead. Then you don't have to worry about like, not having fumped or not having log or debug or whatever. So other cool tools worth knowing about. E.g., if you want to do like large-scale refactoring, or actually let's start with Go rename. If you just want to rename something, it's easy to do it kind of search and replace in your editor, but if your variable is called like B or something like that, you're going to get every B in the file. So Go rename not only renames it like type-awarely in your local file, but every package in your GoPath workspace, it'll rename it all safely without breaking your code. And if it ever introduces an ambiguity, it'll just say, nope, I can't do this because this conflicts with this one, and it'll stop. So, and this has an interface for IDEs to hook into. So you can like in Emacs or Vim or Sublime or IDEA or whatever, or IntelliJ or IntelliGo or whatever they're calling it. They're working on like Go integration. But you could just like do variable renamings and refactorings and splitting a package in two and jumping to definition. Like Oracle does all that. So all the things that people always asked us about, do you have IDE support? Basically, we're building libraries and command line tools to like do all those things. And so then every editor can plug into those sorts of things. So that's all coming along. EG does refactoring where you write, is based on like Java's refaster where you write the code look like this, and I want the code to look like that. And whenever you see code with this structure, pattern match against that AST, and then generate this code instead. And it will go over your whole code base and like do transformations for you based on the patterns that you define. So all this sort of stuff is fun. In terms of the future, Go 1.4 is not the future. This is an old slide. But anyway, so Go 1.4 has a fully precise garbage collector of a stack and heap, and it like compacts the stacks as necessary. The runtime has started to be converted into C to Go in Go 1.4. The runtime is things like maps and channels and the scheduler and the garbage collector and all this stuff. But the garbage collector and scheduler in Go 1.4 were still in C. Android support started to be added to Go 1.4. Which means, I'll talk about that more in a little bit, has internal packages, so you can have, this is internal packages where you can have a package that has like public stuff, but it's only public stuff for your other packages, but not to anyone else on the internet. So if you had package foo and package bar that wanted to share some stuff, you can make internal BAS, and foo and bar can both use BAS, but no one else could access it except for things under that same directory. So that was only for the standard library in Go 1.4, but in Go 1.5, that will be open to everyone on, everyone on the internet through the Go tool. Little things, standard library, cleaned up like always. The profiling tool is now in Go, so it works better on Windows if you don't have Perl installed. And then after Go 1.4 came out, we switched to Git. So we're no longer using Mercurial. Our code review, we're now using Gerrit instead of Rietveld, which was terrible. We're now using GitHub for our issue tracker instead of the code.google.com one, which is shutting down. So basically, we like it. I think we're moving faster now because we just have better tools, and more people use Git anyway. So the present, we're now working on Go 1.5. Go 1.5 will be out. So normally we do a 6-month release cycle. Go 1.1 does a 1-year release, but after that we've always done 6 months. But because we realized we kind of screwed up the timing of the original 6-month release cycle, we always had the releases at summer and like Christmas, and everyone was going on holiday. So we decided to shift it by 2 months. So we made this release be 8 months just so we can future 6-month releases will land on times when not everyone is out of the office. So and also this release is going to be really big. So we have a concurrent garbage collector, and all the whole tool chain, all the compilers and linkers and assembler is all in Go, and the runtime is all in Go. So there's a link to the garbage collection roadmap, and there's kind of a document about if you go to Golang, I think I'll put these slides up somewhere, but Go 1.4 GC has kind of a link to the spec and plan of the garbage collector and papers about it. But instead of just being a stop the world mark and sweep collector, it's now a stop the world concurrent mark and sweep collector. So most of the time your program won't be stopping, and the worst case guarantee is that you'll only get 10 millisecond pauses. I mean, in practice it'll be much less than a millisecond, but it will stop running. It'll stop the world part after 10 milliseconds, and then the other 40 milliseconds of these 50 millisecond time slices, your mutator threads, the ones that are actually running your Go code, will actually help take part iteratively in the garbage collection. So that's coming along great, and that's basically the main focus for the release. We also have more ports. So there's ARM64, 64-bit ARM support, 64-bit PowerPC support, and then also little endian PowerPC 64 support, all for Linux. And then for ARM, we have Darwin ARM and Darwin ARM64. So basically, these together are iOS support because the Mac App Store won't, after I think next week or something, or next month, you can't submit an app to the App Store unless it's a fat binary with 32-bit and 64-bit ARM support. So once we have both of those, you'll be able to do iOS apps in Go. And somebody is also working on Plan 9 ARM support. It's my water. So yeah, so the two main use cases that we're working on for mobile support for both Android and iOS is the kind of full screen games use case, which is just give me the whole screen to work with, give me GL and sensor input and all this stuff, and you don't get the platform UI elements, drop downs and little buttons and scrollers and web views and all this stuff. You basically just can draw GL stuff. So you can make portable games and cross-platform games with this. And then the other use case for both Android and for iOS is you want to do your UI stuff in Java or Objective-C or Swift, but you want to share a lot of logic, maybe all your networking code or your business logic, and write that in Go, and then just embed it in these things. So we're making it possible to write a Go package that has some interface that you want to use from your mobile app, and then it will auto-generate the proper Java or Objective-C or Swift bindings from your Go package definition. So that's coming along. It's not direct. Parts of it are tied to the Go 1.5 release and trying to get the proper tool chain support out, but a lot of it is happening outside of the Go tree on an independent release cycle. I find this the most exciting thing, that in Go 1.5, there's no C code left anymore. Everything is written in Go. The compiler is written in Go, the linker, the assembler, the runtime, the garbage collector, the scheduler, hash maps, there's absolutely no C code left. So yeah, so you use Go 1.4 to compile Go.15, or Go.1.5 to compile Go.1.6, or actually the plan is for Go 1.4 will be the language that you need to compile all Go releases going forward until we decide, we really need something else. So you should be able to compile Go 1.6 with Go 1.4 and stuff like that. And other cool stuff is cross compilation. Does anyone here like make a Linux binary from their Mac to ship to production and stuff like that? So you know how you have to run make.bash first before you can actually run like Go OS and Go Arch and compile it? The plan is for Go 1.5, you won't need to do any of that step. So at any point with any checkout, like you get it from Debian or you get it from your distro, you could just set the Go OS and Go Arch and build any binary from any distro without having to do a pre-build step. So that's fun. So as part of that, the compiler and the linker and stuff all started out in C. So Russ Cox, I encourage you to watch this talk and look at the slides. He wrote a C to Go translator. It's very kind of specific to the Go compiler's style of C and the subset of C it used. But basically, he auto-generated a lot of really kind of ugly Go code. And then from that ugly Go code, he proved that it was equivalent. It generated the exact same output. And then we used all of the Go refactoring tools, which I talked about earlier, like this EG and Go rename, to transform the Go code into less ugly Go code. And this is kind of the process we've been going on the last couple of months, is turning the compiler and linker into something that's like halfway respectable and halfway looks like Go code. Because right now it kind of looks like C code that is in Go syntax. So that's ongoing. Maybe I'll show this actually. So has anyone write JavaScript? Some? Anyone use this like Chrome trace browser to like, anyway, so we stole this code basically, and instead of feeding it JavaScript trace input, we're feeding it information from the Go scheduler about when Go routines run things and stuff. So then you could view your Go program as if it's in the Chrome browser. So hello Munich. So you can run like a unit test, like do I have it here? You can just like do a normal Go test or whatever, run blah blah .bench. In this case, I did like client server parallel for something, and you say trace equals trace equals trace, bench time equals 100 milliseconds, blah blah blah, and it'll run this. We'll run this out. Let's call this trace 2. Oh, that's all going. Anyway, but it writes this file that then you run go tool trace on it with a binary, and you get this little thing where you can zoom in, and you can see like what things are doing. You can see, okay, there's the garbage collector running its sweep. And you can see like here's the size of the heap, so you can like zoom into like different parts, and you can say, oh, what was happening here where the garbage collector was shrinking things down. And you can see here's the garbage collector was running, but only on one processor. The other processor was still running your code. And then here was the part where it actually stopped the world, but only for a millisecond here from 267 to 268. These units are off by 1,000 right now. That's a bug that we're waiting for Chrome to fix in their thing, and then we could export the right units to them. But yeah, you can see that like the garbage collector now runs concurrently with other code running, and you can like zoom in and like actually see like what Go routine was running on what processor, and number of threads, and what system calls were all happening. And you can also see these stats about like all your Go routines. Like here's how many you had from I had 331 in this test of the serve one, and how long they were executing. And this will probably be cleaned up, but these are kind of the raw numbers right now. How long it was waiting in the scheduler, and you can see like all the other profiles like I/O blocking and syscall and the scheduler latency and all this sort of stuff. So. So that's kind of going to be the focus of Go 1.5. You'll get tracing, a runtime that's all written in Go instead of C. You get a new garbage collector that is responsive and doesn't have long pauses. Generally, the Go garbage collector doesn't really have long pauses unless you have certain types of applications which either can't tolerate any latency or allocate tons of memory or something, or have lots of interior pointers, something that confuses the garbage collector. But in Go 1.6, there'll be a new SSA intermediate form in the compiler. Now that the compiler is written in Go, it's less painful to hack on, and people are having fun actually writing Go code instead. And so there's a new intermediate form that people are adding a lot of optimizations to. So the generated code will be a hell of a lot better. Right now, if you look at the actual x86 or ARM code that comes out of the compiler, it's kind of embarrassing. But surprisingly, it's still like, how many times X faster than scripting languages. I'm not going to name any particular scripting languages because they're all pretty slow. But it's kind of surprising that Go is as fast as it is, kind of on accident, just by virtue of generating code, but the code isn't really necessarily any good. So a lot of people care about that and are working on an intermediate form to make the generated code actually be good. Probably a new scheduler. I don't know. We haven't really planned Go 1.6 too much. The SSA form is like the most prominent thing. Go 2, maybe one day, but there's no actual concrete plans. Outside of the core, I've been working on HTTP 2 support. The server is pretty robust and usable, so if you want to actually use that, I am. Other people are. Have people heard of gRPC, the new RPC protocol thingy that Google released recently? It uses that. So actually, people have heard of protocol buffers. Have you guys heard of protocol buffers? So anyway, so all Google APIs going forward will be able to be accessed over JSON or protocol buffers, and over protocol buffers will be over HTTP 2. So you basically open up the HTTP 2 connection to Google, and each one of them is independently flow controlled, and you can just do tons of little requests or whatever. And so we open sourced all of that, clients and servers, and it's all based on HTTP 2, and it uses the same HTTP 2 library that will be merged into the net HTTP package in Go 1.6. I'm not going to try to get into Go 1.5. There's not enough time, but the plan is for Go 1.6, if you have a HTTP server, it'll just speak HTTP 2 for free, and you don't have to change any of your code. All your HTTP handlers will still work and all this stuff. But then ongoing work, like I talked about mobile, Android, and iOS support, all the various little tools. I didn't talk about GCC Go much, but it's keeping up. It supports more operating systems and architectures. It generates better code. I talked about how the main Go compiler, the lowercase GC, generates pretty crappy code. GCC Go generates really good code because GCC has like 68 different passes it does for optimizations, but it lacks things like the precise garbage collector, and the escape analysis, which makes the main Go compiler really nice. So it's kind of a trade-off sometimes about which compiler is better. But they're keeping up, and it's a friendly little competition. There's other fun ones. I particularly like this TARDIS Go compiler that translates from Go to Go's SSA form from the external Go types package that uses this other SSA form into Haxi, which is this other language. And then there are compilers from Hax to go to like 16 other languages, one of which is JavaScript. So if you actually look at the demo here, where is the demo? So there's this little program here that has two Go routines running this little for loop, and it's running this animation. So this is written in JavaScript, but the program was actually written in Go, and it was just compiled to the browser. So it's kind of cool that I think he passes now all the unit tests in the standard library work when they're run in the browser. So that's kind of impressive. There's also LLGo, which is LLVM. It's a Go compiler that uses the Go types package that generates bitcode that then generates like Pinnacle or whatever LLVM can output. So those are fun compilers. There's basically a lot of stuff going. It's hard to kind of keep up with everything now, but that's a little overview, and we can do Q&A now. You can write code. Red shirt.
So, unit counts are now the code range over the internet. Do you know of any efforts of making Go apps standalone without running a unit command?
What do you say is all the rage these days? Oh, question is, unikernels are all the rage these days. So actually, back in the day, there was in the Go tree, before Go was even out, there was a directory called runtime. It was runtime tiny, and it was an implementation of Go that didn't require a kernel. It ran directly. And there's a couple other things like that now too. There's 2 people have implemented hypervisors in Go that emulate all like the Linux system calls, which is kind of the reverse of what you're asking. But there have been a number of people now that are like basically implemented the Go runtime in a kernel that doesn't require one. Some of them are kind of toys. One of them bit rotted, but I mean people have done it at this point. So.
Would you try to merge example stuff eventually into the Go standard distribution?
I mean, so generally our policy is that the question was, would we accept such a patch into the core? Generally, our policy is if you run a builder, and like, for instance, well, Dragonfly is currently broken, but this is kind of esoteric BSD, and Plan 9, no one really uses it, and I don't know who uses really Solaris, or, you know, whatever. Like, there's some kind of operating systems that you might consider fringe, but to a certain community, they're really popular. So our policy is we will accept your code in the Go core if you run a builder and you keep it okay for releases, then you're responsible for fixes. And if you don't get it all passing all the unit tests after, like, you know, I think it was 3 months or 6 months, and you're not ready for all releases, then we're free to delete your code. So it basically needs a responsible maintainer. We're not going to like take a one-time code dump and say, okay, we'll maintain it for life. But most of these communities have been pretty responsive. And like, there's certain ones that we say are first class. So like most of us use Macs, so like we'll never drop Mac support. Linux support we use on all of our servers, so Linux will never go away. And Windows is just too popular to ignore. So those ones are like kind of the main ones, and everyone else kind of has to fend for themselves. But
what is the status in the dynamic link?
Oh yeah, So the question was, what is the status of dynamic linking? And actually, there's tons of activity on that lately. So Ian Lance Taylor, one of like the main 3 or 4 core Go people, he wrote a whole documentation or a whole document called Go execution modes. And then this guy, not open, Michael Hudson Doyle, I think he works for Canonical. He's been going crazy right now and making this all work. And it's being used more and more, and these patches are all going in. So in Go 1.5, you should be able to do all this. And then the plan for Go 1.5 is also that you can embed a Go library in a C program. It's always been possible to call from Go into C, but Go had to own the execution, the entry point of the program, because Go had to set up the signal handlers, had to own the signal handlers, had to own the virtual memory space. But previously, you couldn't, like, it's easy to embed Perl or Python or Tickle or something in C, because they all have embeddable APIs. But Go never had an API that said, like, init the Go runtime. And here's the signal handler entry points and all this stuff. We basically always assumed that we owned the world. So that should, I think, change in Go 1.5. That's the current plan. So if a C program wants to embed Go, it can, and then call into Go and get a return call. But we'll see. There's a document that lists like 5 or 6 different combinations of this about like how it all works, and I think we're going to get the top 2 or 3 in Go 1.5. Anyone else?
You sent a message about dependencies and rendering to the Golang nuts.
Yep.
And there were like 9 pages of discussions followed up. So I don't know if what's the next steps, and do you have any comments on what?
Yeah. So the question is, why do I suck, and why do I send an email to Golang nuts asking about dependencies and vendoring, and then go on vacation for 2.5 weeks and mute the thread and then forget about it? And this is true. This is the answer in the form of a question. But yes, basically the summary is everyone keeps asking us about dependencies and stuff and vendoring. And internally we vendor everything, and it's kind of the only way to ship a production binary is if you're depending on some third-party code, the answer isn't like, okay, we're going to deploy to production today, so we're going to run go git and see what crap exists on GitHub at this instant in time, right? Like, maybe it was good yesterday, and maybe they introduced some dumb bug tomorrow. But like during your whole QA process, what were you QAing, right? Hopefully you're QAing the same code you push to production. So the responsible thing to do, if you're a company pushing Go code to production, is you take a snapshot of all your dependencies, and you make sure that the thing you push to production matches what you tested. So people disagree with this sometimes, say you need a complex version file format or whatever. So we've always just kind of done this by hand, and we have internal tools, and other people have internal tools, and there's tools like what's it called? GoDep is one. Dependency vendoring tool, blah, 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 for Go, and I think there's one called GoNut. That is Go Nuts with donuts, which is not the right thing. It's called Nut? I don't know. Go Nuts, Nut Vendor, something? I don't know. Whatever. There's two. There's one called GoDep, and there's one called Nut. But they both basically do the same thing. You describe like all your dependencies you want for your project and the versions you want, like what is the version you've tested, and it kind of grabs them all from the internet at that revision, copies them all into like an internal private directory of yours that's in your GoPath workspace. And there's kind of differences about how you declare the things you want and exactly where it copies it. And do you modify your GoPath to have multiple elements, or do you like rewrite all the imports to say like, okay, I'm github.com/me/my project/other people stuff/github/them/their project/foo? Do you have this like really long import path, or do you write that, or does tools do it? Anyway, so the point of this is people keep bugging us, so we finally said, all right, we should bless an official way to do this, and then all these tools like GoDep and Nut can kind of all converge on the standard, and we can let that kind of brew for 6 months or so, and then in Go 1.6 we can maybe like push one of these tools into the Go core and make it official. So I sent out this email before I went on vacation like a month ago now or so, and then I got all these emails while I was on vacation. It turned into the Senta thread with like a couple hundred replies because everyone had their own favorite syntax. We should use YAML, we should use JSON, we should use Go, we should use TOML. And I was like, mute. And so then I forgot about it. It was really nice. And then I came back, and then people was like, God, that's had like 300 messages now. And I was like, oh, whoops. And so I'm actually supposed to revive that thread and make a decision, and well, a couple days ago, and I forgot again. And then you reminded me. Thanks. Yeah, back.
Sorry, I think you should not make it so easy, because you see, I come from the Java world, and it really sucks if you see the gray with all this dependency coming back. So I think I like the approach that you say, okay, you should only have few dependencies, and you should keep them, and you should make them part of your code, basically. And don't start this dependency hell and this upgrade migration hell. Continuous integration. So whenever you take a new version, you check it and you build it into your company. So if you make it easier, it means you're supporting the other part of it.
The question was not a question. I mean, you're saying I hate Maven, and we're contributing to people acting like Maven.
Yeah, you're supporting people starting to act. So you basically are saying stop freezing your system, because you support people who want to statically programs. We want to have people who freeze their code for the next 3 or 4 years. All these problems you get when you come to backup consultants, they come to customers and they have some 6, 7, 8 years old stacks, and you basically fuck with all this old libraries.
But what do you suggest, that we push like to production, like Google or Yahoo push to production libraries that reflect like today's state of GitHub? That's not realistic.
The thing is, you should have proper regression testing, right?
Yes, but still there might be differences like that are not caught by. I agree that testing is important, but we cannot still like rely on unknown state of the packages.
But if you do the proper architecture, you can rely on it, right? You have some.
Well, you could do it if like you maybe like. No, I can tell you what happens, that without, from experience, without a defined mechanism for the packages, people just don't refuse to use the tool and consider it not production ready.
So you said you do it manually, right? So you said that internally Google would do it manually.
No, we have a tool.
Okay, so which one is similar to this? So you would get a best practice to start off with.
Kind of none of them. We don't describe it. So like. It's gone. Internally, if we're using like say the foo library, and we notice that somebody upstream added some feature we need or fixed a bug that concerns us, we make one change that first updates us from version 2 to version 3. We build it and test it, and we have a tool that like slurps in the latest version or slurps in a specific version and puts it in the Google source tree. We have like basically we have one source tree for all of Google. Gmail and the self-driving car and Bigtable and MapReduce are all in basically the same tree. And so once we kept checking in there, we send out the CL for review, and at the same time, all the unit testing frameworks, whatever it says, runs all the tests in the world to make sure we didn't break the self-driving car or Gmail or Bigtable, and make sure it runs all those unit tests. And if it proves, then we like check in that new version of the foo library. And we have a file that says, like what version that we're using of everything. So we kind of have a snapshot of it and a description of that we're using this thing, but we don't check in a file that says, here's what we want, make that so. We just have a command line tool that says, update this now. And basically it's on demand. Whenever someone needs a new version, they're responsible for updating it and making sure that they didn't break anything in the world. But in general, people like kind of declarative config files where they can. Oh, and so like GoDep actually has a mode like that. A GoDep has a mode like update X, and it updates X, and it updates the config file to say, hey, I'm using this version. So, I mean, GoDep is probably the closest, and it's probably better than the crappy tool I wrote. So.
There was a lot of people complaining about the lack of generics in Go. And then in 1.4, people came. In 1.4, the answer was kind of, okay, use Go generic now.
Mm-hmm.
Kind of. But yeah, it's not real generics, but it's like generic.
Okay, it is true. Go does not have generics. It is sometimes painful. Once every 3 or 4 or 5 months, it's painful. Briefly, and you copy paste and you work around it and you move on. And yeah.
My question is, is there like a plan to bless a way to use Go generic, because the blog post is kind of vague?
The question is there a plan to bless any generics approach or specialization or code generation for like? Not really. I mean, like. Go generate didn't give the community anything that they couldn't do before. So if someone wanted to do, and there were projects that did code generation from like generic kind of types before. There's one called like got or something like that. That you wrote a package using the type T, and then you could say like got generate or whatever, and it would crap out a package that replaced all the cases of T with the type you wanted. So. These existed already before. So go generate is a cute little alias that you can say go generate, and it just runs all the things in a package, but it's nothing you can't do with a 2-line make file either. So yeah, I don't think there's an official plan to bless something. It's just it made our lives easier. It cleaned up some of the things in the Go tree where we were like generating like Unicode tables or time zone database tables and stuff like that, but it's not really the answer to generics. We would still like to see generics at some point, but there's no great plan. There's been a lot of proposals that think that the problem is about syntax, and the problem isn't syntax. The problem is kind of like what is the runtime representation and how's the code and how do you make sure that the language stays simple and readable and you don't get like terrible error messages. It's kind of like all the programming and the large problems that come out of having, I don't know, like we kind of prefer to pay the price of having things a little bit more complex and painful and tedious once for the programmer to make everyone else's lives easier. And it's a trade-off, and it kind of sucks, but we prefer to stay simple for now. And plus, everyone's like busy working on the compiler cleanup and the toolchain cleanup and new garbage collector that no one has really had time to think about the language. And plus, when Go 1.0 came out, we kind of said, the language is frozen, please use it, trust it, and we're not going to be changing it and breaking it. So if generics were added, pretty much the whole standard library would be redone, because you wouldn't have like the strings and bytes packages, and the I/O interfaces would all be different, and the OS package would be all different. So you would have to have two parallel standard libraries. And like I think D went through this whole problem where when they had two different standard libraries and kind of fractured their community. So it would be major, and I think no one has time to even think about it until all the existing. Yeah. Well, I'm just using your question to get rid of all the generics questions after this. So.
Do you ever have security audits of the core library? So particularly on crypto, do you get like somebody like Matthew Green and you like give him some money and say, go through OpenPGP?
No, but yeah, this guy, Adam Langley, he like does all of kind of Google's crypto and like Chrome's crypto and the Google Web Server's crypto, and he like works on OpenSSL, and he works on Boring SSL, which is like kind of the cleaned up fork of OpenSSL. Like, and he's done all of Go's crypto, and so he's very modest, and he says like, oh, we haven't had a proper security review. I wouldn't trust it in production. But honestly, I would not trust OpenSSL in production at this point. I wouldn't trust any C code in production. Like, at least Go is memory safe, and there's whole classes of vulnerabilities that Go is not susceptible to. So I would trust I can actually read the TLS implementation and the crypto implementations in Go and actually understand how the crypto works because it's really short. I can also read our JPEG implementations, our zlib implementations, like all these stuff where I read the C code and it's all like macros and jumping all over the place, and so people worry about the lack of code audits, and yeah, it's true. We haven't had any proper formal code audits, but at the same time, it's written by a guy who's kind of a crypto expert.
What about pull requests? The NSA, for example, tried to inject something into Swift.
Well, Adam, the question is, how do you know your pull requests don't have vulnerabilities? But Adam kind of reviews them all. So, and if we get one, we look at it and we're like, no, I don't know, pass it to Adam. And then, actually, I just mailed him, and I was like, here, there's 5 pending code reviews that are waiting for you for crypto stuff. He was like, oh, cool, great tool, because I wrote this tool that shows like all the outstanding code reviews for people after we switched to Garrett. And he was like, oh, great, can you make your tool give me more hours in the day, too? Because he does so much crypto stuff around Google. But
which services or open services you already wanted to go, or maybe you use it?
I mean, the ones I can talk about is like the Google download server I ported. I've given a bunch of talks about that. That serves all like, Chrome downloads and like whatever. There's like thousands of downloads from like any random Google product that comes from that. That was in C++. It's now in Go. There's a bunch of big ones, but YouTube. All of like YouTube's database traffic goes through a MySQL proxy that's open source called Vitesse. GitHub, YouTube Vitesse. So if you've used YouTube, it's gone through this. If you download something, if Chrome has ever auto-updated, it's gone through a Go thing. There's a couple much bigger ones, but like they're shy and don't like to talk, and I can't spoil their surprise. But.
So you plan to introduce any new language features into Go?
Probably not. The question is, are there new Go language features coming? Probably not. Every release kind of has as close to 0 as possible. There's a page where it says project release history. And it says like when there are language features. I think changes to language. So in Go 1.4, instead of saying like underscore equals range. When you didn't care, you could say for range on a channel, and that was it. You know, there were basically like small little cleanups. Someone pointed out that something was inconsistent, and we're like, no one ever writes that anyway. And we're like, well, okay, we'll clean it up and make it consistent, but
that's nothing big planned.
Nothing big planned. I mean, I think maybe once like we generate good code and we have good runtime and a good garbage collector, maybe everyone will relax and think about like, okay, now that we've been using this for, I've been contributing to Go almost for 5 years, and generally we've all been so busy working on things that we haven't had time to think about like, okay, what should we fix now? Because you never know, like when you make a mistake, you were like, well, maybe I didn't make a mistake. Let's see how it feels in 6 months, and then it's 4 years later, you know, and you're like, at that point, you're used to it. So, yeah, maybe we'll get a break and think about it, and then we'll realize, okay, maybe that was a mistake, but who knows?
Speaking of this Go for mobile, like Android and iOS, do you have any kind of big plans? It's going to be like a big tool for developers, or just like a niche support of another platform? What are your plans?
So the question is, outside of Android and iOS, do we have big plans for a player?
Just for Android and iOS, do you think it's going to be something that like lots of developers are going to use for actual development, or just like a smaller feature support for another platform? Or do you have plans for mobile actually?
Well, you know, the mobile's the future, right? So you gotta support mobile. But I mean, like, I think pretty much everyone on the team has kind of like written apps at some point, and it's kind of painful to write 3 versions of everything, the web and the Android. So it's actually kind of nice to know that you can run Go on the server, Go in the browser through something like, you know, TARDIS Go or Gopher.js, and compile Go to the browser, and you can use your business logic on Android apps or on iOS device. So there's not a total story yet, but we're trying to get all the pieces in place so we can see, like, does this make writing apps a little bit easier to like share most of the logic? But it's largely an experiment at this point.
Are there any broad ideas, you know, helpful for newbies to start working with Go? Because the only thing I found decent is one plugin for IntelliJ. Everything else was, to be honest, a piece of crap.
Yeah. So the question is about like IDEs for Go. I mean, on the team, some people use Emacs, Vim, Sublime, Xcode, Acme, which is like this weird like Plan 9 editor that like all the Plan 9 people use. So even on our team, there's no agreement about what to use. But the cool thing about Go is that it's simple enough in general that you don't really need an IDE to write all your code for you. There's things like Go imports, which adjust all your import lines, which is kind of like, you know, the same tediousness of Java, where you have Eclipse or IDEA, IntelliJ, like updating all your imports. So, but the variable names and class names and all the code completion, you don't quite need as much in Go. Like, so I don't use anything. I just type it all out.
I spent 5 years learning how to web to prepare by these tools.
Yeah, but I mean, compared to like when I write Java, I also use tools, because you kind of need to use tools to write Java. It's kind of like almost not possible to write Java by hand as a human. But with Go, it is actually possible as a human to write Go. So, but there are people. So IntelliJ, so you like IDEA IntelliJ? Like, but you said they're. So they're actually, I don't know if this is public, but they're working on it. They're working. I think it's public. I don't know, but they're working on Go support.
I think as long as you don't use the C compiler, some C routines which we are using currently, the refactoring is broken that out. But otherwise, it working nicely, even with Eclipse, if you don't want to get that one. It's okay if you develop Go on Sublime, or refactoring is working if you just Go. If you use C Go, it's difficult.
Yes, so our general approach for editors and refactoring is we're trying to like build all these command line tools and libraries that understand Go code and refactor Go code as libraries. Then we expose them via whatever entry points editors want. So if Emacs or Vim or whatever wants a command line interface and they wants to parse standard out in certain ways to understand it, we'll give them the information. So if you want to like do jump to definition and your cursor is on a certain word and you want to jump to where it's defined, instead of implementing that in eLisp and in Vim and in IntelliJ, instead you shell out to a program or to a daemon and you ask a little server that's running as a child process of IntelliJ and say, hey, what file and byte position or line number and column should I jump to get to the definition of where my cursor is now? And we'll answer that question for you. And we implement that once in Go, and then all editors benefit from it. So, and also like with refactoring, like there's this Go rename tool, and you could say like I want to rename this thingy from or this thing at this file and byte offset to this thingy, and your input can be like a package name and a type and a field, or just like a type name or just like some variable that's within a package, and it will either like do everything in the whole world over all files and all packages in your whole workspace, or it will return and say, sorry, I can't do that. And it's like atomically yes or no, like I could do it. And so editors, instead of having to implement all these refactoring support themselves, they just call this. So that's kind of how we have meetings with all the people who do like Sublime and IntelliJ, and we're like trying to give them things like this to make their lives easier. So that's coming along slowly, but it's probably, we've never prioritized it because Go is very terse. It's not as verbose as Java. So, and we also just don't use big IDs ourselves, so we've never really cared, but we know other people care.
You mentioned gRPC. How does Google use it internally, and what's its use case out in the wild?
So internally, the question is like gRPC and what is Google's plans for it and how do we use it internally. So internally, we use protocol buffers. The new hot term is microservices, which is just doing RPCs to servers that do RPCs to servers that do RPCs. But I know Google's been doing this for approximately forever, and this is how like all the servers just have little interfaces. And so basically internally we have a system called Stubby that everyone knows about, and everyone always asks, when are you going to open source Stubby? When are you going to open source Stubby? And we release protocol buffers, which is the serialization format for messages that we send over the wire. It's a binary protocol. It's really fast and efficient. And people always say, okay, so you release protocol buffers, and it has syntax in the protocol buffer for declaring services, but it doesn't generate code for it. And there's no implementation of the services. Like, how do you actually write a client or a server? And we always were like, oh yeah, we didn't release that code. It was kind of embarrassing. So we have this like really fast, nice implementation internally, but it's built on like 10 years of kind of crap that's kind of like weird and shifted over time, and we can't really open source it because it's too weird and graded. So they took all the good ideas from it and redid it all and cleaned it up, and they built it on top of HTTP 2. And so it has all the same features as our internal Stubby, but it's like modern transport and uses all like the modern protocols and stuff, and that's called gRPC. And so then internally we're going to like accept gRPC from the outside world, and we're like starting to use gRPC internally, but then there's like translators that turn gRPC into Stubby for inside of our network. But and if you don't want to use gRPC, gRPC also lets you express everything in JSON too. So if you like JSON, if you like to look at it in Wireshark or whatever because it looks pretty, but you like to waste all that CPU time encoding it and wasting all that network bandwidth, you could do JSON. But if you just want to like send the raw bytes, you could do that too.
So you mean you would also then get like web clients talking gRPC then as well?
Yeah. So you can have JavaScript talking to it over JSON, or you can have JavaScript sending the raw protocol buffer bytes too over HTTP2. So I think there's this project called GoKit.io. It's funny, I just typed GoKit.io and it redirected back to where I was. But GoKit.io, which is this GitHub page, is basically a collection of packages for basically doing microservices and like all the logging and infrastructure and monitoring and like tracing RPCs and yeah. So anyway, there's metrics and transport and logging and anyway. So they're also looking at gRPC as kind of a component of all this.
So it's like a replacement for REST?
Well, REST doesn't really mean anything, but yeah, kind of. I mean, REST kind of means you use HTTP verbs and JSON generally, but I mean, that's not particularly efficient. You don't necessarily get like throttling or rate limiting or pushback, and like it's not JSON isn't particularly efficient or particularly low latency. So.
How many big players that have started using this outside of Google?
It came out like last week or something. So. Oh, the big one was Square. It was done in conjunction with Square. So they were doing something very similar at the same time. Square gRPC. Yeah, so they did this blog post when it came out. Yeah, so they basically, I don't know, a lot of people at Square and Google have gone like back and forth, and they know each other, and they were talking, and they're like, oh, we're about to release this thing, and then Google was like, hey, we're about to release the exact same thing, and so then they got together, and I think they merged their projects because they were like identical and made gRPC. I don't actually know the history. I'm making things up. But it was something like that.
If you could redesign one of the standard library packages, which one would you do?
Oh, I would delete half of them. Actually, I started working on a document. I think it's called golang.org/std_y. Yes. And I put y is x in the standard library because I'm working on a new FAQ entry about like what does it take to add something to the standard library, and the answer is basically going to be like, oh my god, nothing goes in the standard library anymore. It's too big. And so I'm making this column like, here's the package, what needs it, should it live somewhere else, like was this a mistake? But at least is it complicated? Like at least maybe it should live somewhere else, but it's really complicated, so like maybe it should be maintained. And then like a justification of why we made this mistake in the past. And a lot of them are so the main decision is the standard library should have HTTP. That was kind of a decision. Because it should have HTTP built in, it needs to have TLS built in. Because it needs TLS built in, we need a whole bunch of like crypto ciphers and stuff like that, everything that TLS uses. So you see like lots of like crypto stuff that's in the standard library because we needed them by TLS. But then there's a lot of stuff like, why do we have a JPEG and GIF decoder in the standard library? It's cute, but it's not really necessary. Or like suffix array data structures. Like we needed it in GoDoc for searching, but now GoDoc isn't even in the standard library anymore anyway, so it's kind of just there on accident. There is this, where is it? Log, syslog. Anyway, we have a package, yeah, log, here it is. We have a system log package, but we've never used it. And it could be on GitHub. No one really knows what it's supposed to do on Windows. And so we wish, like people keep sending us patches to it, and we tell them to go away. We have fast CGI support and CGI support, but no one has used CGI for like 15 years. And so we don't know why we have that. There's a bunch of really weird things like tab writer, which I think was used by like GoDoc or something, but should be in internal packages, but we didn't have internal private packages at the time. So there's a lot of embarrassing stuff in the standard library. I forgot your original question. Oh, what would I? Oh, Reflect. Well, we need Reflect. It's used by everything. You should have seen the old version. The old version of Reflect was worse. But yes, it's not amazing. But the advantage of it being a pain in the ass is it dissuades people from using it. So anyway, I think we should wrap up and have beer, but we can keep talking about Go afterwards. But thanks.